If we have a color scale map representing something like topography, depth structure, temperature, or any other data set where colors correspond to numeric values in an image format, such as a scan map, PDF, JPEG, PNG, or any other non-GIS image format, and we want to convert it into a GIS raster grid, we would use the color scan color to values tool. And we'll see how to do that conversion with this depth map. It's a PNG image that has been georeferenced with the normal Arc Pro georeferencing tool, so it's in the correct location. And we can see it's an image. If we click on it, we can see in the pop-up the values just represent a color code. And color scan works with 3 or 4 band color codes. And we want to convert those codes into the actual measurement that these colors represent, which in this case, as we can see from the legend, is depth in meters. And we want to remove everything overlaid on top of the color scale, such as contours and text, so we are left with a clean grid of values. Once it's converted to a raster grid, we can of course contour it again. We can also analyze the data, change the color scheme, view it in 3D, combine it with other GIS datasets, or export it to other software packages. So to do the conversion, we go to the color scan ribbon and select the georeferenced image from the drop-down menu. It is now the active raster, meaning any color scan tools will be effective on this raster image only. Then we want to select the color to values tool and we get the tool dialog. I'm going to reposition it so all the functions are visible. This setting here, the color tolerance, I recommend setting to 7. I'll talk more about what that actually is a little later. To start, we need to activate the Select an Area tool, then start tracing around the area to be captured by using single mouse clicks. And to finish, double click. The area will now be processed and all pixel colors will be sorted into groups of similar colors. The number of color groups created depends on the color tolerance value we set. A lower tolerance will produce more color groups. And how long this takes depends on how dense the image is. That is, how many pixels the image contains. A very dense image can take some time, so be patient. Once we have all the colors in our selected area, we need to assign a value to each color. We're trying to create a grid of values, not a grid of color codes. So we need to convert the colors into numeric values. We do this by assigning a value to each color group using control points as references. For example, we can use the contour value because we know that the color at each contour corresponds to its numeric value. We then use the color picker tool to click on the image, which highlights the matching color group in the dialog. After that, we enter the corresponding value into the form. And we can continue this process until we have established a sufficient number of control points. We don't need to define every color group manually, only enough to allow the remaining values to be interpolated. Obviously, the more control points we have, the more accurate the conversion will be. And that is one method we could use for value allocation. But in this case, we have a legend or key, so it makes sense to use it. And where we have a key for the color scale, we can use the Capture Scale tool. Once the tool is selected, use the mouse to make one click at one end of the scale and double click at the other end of the scale. This then populates the color scale dialog. We then use the color picker again to click on the scale near a value, which highlights the corresponding value in the dialog, and we enter the value for that color. So this is the same method we use to create control points from colors near contours. Once we have enough, we use this calculate button to interpolate what the values should be and fill in the blanks. If we tick the all values box, it will interpolate beyond the first and last value. We'll remove the white color values that have been picked up when we went beyond the color scale. Then we select the transpose button, and that just copies the values to the corresponding colors in the main form. So we are back in the main form. So we have a lot of blank values, and if we go to the whole image, the blank values are for colors for the overlaid features. So things like contours and text. We don't want to leave them blank or they will be allocated a 0 value. Instead, we have options to allocate no data, which would just be a hole in the grid, or interpolate, which is going to calculate the value based on the neighboring values. Now, to save time, rather than picking interpolate for every blank value, we can just select the populate unfilled button, and that will set everything that hasn't been allocated a value to interpolate. So we'll get a calculated value for those colors. Just make sure you have enough values allocated for the interpolate algorithm to work with, or you'll get an error. If the image contains large features that obscure part of the color surface, such as text boxes, legends, annotations, or in this example, an arrow, we can create a polygon to cover the affected area. And a value can be allocated for that area, or it can be interpolated from the surrounding color data. Now we're all set up, we can create the raster grid. We do that by going to Save As, and we can save either to a geodatabase or to a file location. If it's a file location, we will get a geotiff. In this case, we are saving to a GDB. Now the saving process can take some time, because during this step, all the interpolation is being run and all those calculations are being made. So again, be patient. When it completes, the raster grid will be added to the project and will be displayed in the default black and white. And we'll give it a suitable color symbology. And if we turn off the georeferenced image, we can see our raster grid, free of those overlays of features and text. And if we use the Explore tool to click on the grid, we can see we get an actual value representing depth in meters at that point, rather than just a color code. Now, that's a pretty good first pass conversion from an image into a raster grid. However, if we zoom in, we'll see artifacts. And on most conversions, you'll likely get some of those. Because of things like distortions around the edge of lines or text, and that creates colors that are similar to those colors that are from our key. So we get erroneous values that are these artifacts, which we want to remove. Now, if the artifacts are large, then I recommend using the color picker to select where the artifact is. That will highlight the color group in the form that is generating this value, and just change it to interpolate, and that will calculate through the artifact. Now the form remains open after saving, so you can always change any of the values and run the raster grid creation process again. Make sure to call the new raster a different name when saving, that's all. But with these small artifacts affecting a number of different colors, using the Esri pixel editing tools will give a very good result. They are very easy to use, they're quick to use, and we have a video showing how to use the pixel editor. And the link to that video is in the description. It's not complicated, so take a look at that. And just with a bit of tidying up on the artifacts, you will get an excellent reproduction of a surface into a raster grid of values from your georeferenced image.